Let's look at problem 2310, sum of numbers with unit digit key. So for this problem, we're going to provide a solution called decomposition and modulo operation. So first, I'll go through the statement of the problem, and then I will explain the idea. And finally, we will write the code and explain and test the cases. First, let's look at the statement of the problem. So given two integers, num and k, consider a set of positive integers with the following properties. First, the unit digits of each integer is k, and the sum of the integers is num. So we are required to return the minimum possible size of such a set, or -1 if no such set exists. So note that the set can contain multiple instances of the same integer, and the sum of an empty set is considered to be 0. And the unit digit of a number is the rightmost digit of the number. In other words, it's the result of the number modulo 10. So with that said, let's look at two examples. In the first example, we have num 58 and k equals 10. So the output is 2. So they give two valid sets. One is 9 and one is 49. So for the second one, one is 19 and the other is 39. So for example 2, so the return is -1, so no valid set. In the third one, so the return is 0, so as specified by the note 1. So the constraint about the number is that it has an upper bound that is 3000, and the k is greater or equal than 0 and less or equal than none. So with that said, let's look at the method and the main idea. So here the method is called decomposition and modulo. So the idea basically is some mathematical operations or ideas using the modulo. So given the num and k, so assume that a set with n elements does the job. In other words, the sum of these n numbers equals num, and each of the number has such a form. In other words, xi equals 10 times yi plus k for some number yi. So the k actually is the result of xi modulo 10, which is equivalent to say xi has units digit k. So if we change a little bit for the first equation, so we will get something like this. We replace xi by its unit digit representation. So we have 10 times y1 plus k, 10 times y2 plus k, and finally 10 times yn. So add them together equals num. So if we do the grouping, we get n of the k's, so n times k, plus 10 times y1 plus y2 plus yn equals num. So as we have no constraints on the y1 up to yn, so they can sum to any non-negative number with last digit 0. So the problem actually can be transformed to, if we can find, or if to find the minimum n such that n times k equals num in the sense of modulo 10, and also because this y1 up to yn is non-negative, we require that n times k is less or equal than num. So that's the problem. So as a number modulo 10 has at most 10 possibilities, like from 0 to none. So we need only to consider n in the set from 0 to 10. So 0 is for the case num equals 0, and 10 is for the case when k equals 1 and num modulo 10 equals 0. So let's look at the two examples in the problem. So in the first example, the num is 58. It equals 8 modulo 10. So we want to find n such that n times 9 equals 8 in the sense of modulo 10, and n times 9 less or equal than 58. So we can choose the smallest one, that is 2, right? 2 times 9 is 18. 18 equals 8 in the sense of modulo 10. So in example 2, the num is 37. So 37 modulo 10 is 7. So we want to find n such that n times 2 equals 7 in the sense of modulo 10. So this is impossible. The reason is that 7 is odd and 2 is even. So that's about the two examples in the problem. So now before we write the code here, there's a challenge. So can we make connections of this problem with the coin change problem? Okay, with that said, let's look at the implementation of the above ideas. First, I'm going to treat the special case, the edge case. That is, if num equals 0. So in this case, we're going to return 0, specified by the problem. Second, for the generic case. So for the generic case, first I will compute the target. The target is nothing but the num modulo 10. Right. So then I want to find n such that n times k equals this target in the sense of modulo 10, and with the constraint n times k is less or equal than the value of number. So for this purpose, let's iterate for I in range 1 to 11, because we can also need to consider the case 10, right? So yeah, we check this condition. If let's use n here. If n times k modulo 10 equals target, and if n times k is less or equal than num, right? If this is the case, let me print and put another parenthesis. So if this is the case, we are going to return n. Otherwise, if we cannot find such a relation, we are going to return -1, like in the example 2. So with that said, let's check the two examples. So this is for example 1. Now let's look at example 2, 37 and 2. It also passes this case. Now let's look at the generic case. Yeah, it passes the generic case. That's about it. To have an overview, so first we translate or transform the problem into another format. Then we do a simple for loop to find the minimum n required to satisfy the condition in the problem with the help of modulo operation. That's it. Thank you very much.